We're going to take a look at projectile motion. We've actually looked at this before in the very beginning of this unit, but now we're going to we're going to add rounding using Desmos. All right, so a toy rocket is launched from a table. The height of the rocket, y in feet, is related to the time after launch in seconds by the given equation. Using this equation, find the nearest tenth. Okay, so here's the rounding piece that we need of a root, what r of x equals blah, blah, blah. So let's go ahead and put that into Desmos. All right, so you're just typing in exactly what you see. All right, boom. And so here it is. It's been launched off of a table, which is not the ground, I might add. That's why you see it's negative if I click the x-axis. So it's somewhere over here. There's the table. It's 3 feet high. It's launched, it goes up, and then it comes back down. Okay. All right. So that's the projectile motion. All right. So what we are finding is a couple of things. So I'll do one and then you're going to do another. So I'm going to do this toy racket and you're going to do this basketball. So go ahead and type in your basketball equation into Desmos as well. Pause the video and do that. All right. So for mine, I need to find the height the rocket was launched. For you, the height the ball was thrown. Okay, so it's the same situation, only mine is a rocket and yours is a ball. So for me, the height the rocket was launched. Okay, so again, we just talked about it was not launched from the ground. And actually, while I'm here, I'm going to show you a few buttons to kind of make this more visible. If you click on the settings, we can tell the Desmos calculator what we want to see. So for example, on the x-axis, let's say I want to see maybe -1 to +5 only. So -1 to +5 because that's all I need to see on this graph. All right, so I'm going to go here and I'm going to say, hey, make it from -1 to +5. And you see that all it will show if I click the spanner again is from -1 to +5. It just makes it more conducive. All right, now I'm going to do the same thing with the Y because I'm not going to zoom out. I'm going to assume the vertex is actually, I am going to zoom out. So here it is, the vertex at 67. So I want to see, from on the Y, maybe -2 to 67. So I'm going to say, again, I want the X from -1 to 5. And I want this one from -5 to maybe 70. And so that it can appear a little bit more, in my graph, I'm going to say, hey, I want the x-axis to go up by 1. So that means it's going to go 1, 2, 3, 4, 5. And then I want the y-axis to go up by 10. So I'm going to click that and see what that does. Okay, boom. All right, there are lots of lines here, so they might be a little bit confusing. So I want you to go to minor grid lines and take that off. All right, so let's see if that makes it better. I want the x-axis to go up by 1. So I'm going to tell it, hey, don't show me all of this. Go from -1, -12. Go from -1 to +5 so I can really see the graph. And boom, see how it just made it fit? Now, this is not something that's vital. So you fool around with Desmos a little bit so that you can, get to see questions a little bit easier. So now I can see it. Real simple for me. The height the rocket was launched. So I know it wasn't launched from the ground because that can't have negative time. So it's launched from 3, and I don't even know is it feet? What is it? Yep, 3 feet. All right. So for me, it's launched on 3 feet. So go ahead and kind of mess with it and see if you can get it to, show you a graph like this. If it doesn't, or if you're struggling with it, please just come to me and I'll kind of walk you through it. Because this is the first time you're kind of messing with these are called windows, how you want to see the graph. All right, so the height the rocket was launched was 3 feet. For you, how was the ball? All right, the maximum height reached. So again, this is height and this is time. And if I want to be fancy, again, I don't have to. I can go to the x-axis. X-axis is time, and y. And if I do space this way, is it that way? Nope, maybe it's space this way. I'm going to move the time that way, like to more middle-ish. And then this one is height, GHT in feet. All right, and again, it's over here. If I want to move it a little down, is it that way? Nope, it's come on this side, press space, and I'm bringing it down. So if I want to be fancy, right? So, okay, so the maximum height reached. So here is the height. What's the maximum height? Right there. So this is my Y value, so 67 feet. All right, the time that the rocket will hit the ground. Okay, so the rocket hits the ground at, ooh, it's a decimal. Okay, so now I need to round it, because if it wasn't a decimal, I don't have to worry about it. But now I have to round to the nearest tenth. All right, so let's go ahead and see, how do I round to the nearest tenth? So using decimals to round. On a new line, type round. Okay, so let's go ahead and do that. On a new line, type round. All right, to tell the calculator what it is you're looking for. All right, so parentheses, tell the calculator what you're looking for. Well, I want you to round this, which is, I can copy that. I can highlight it, Control C, Control V. So I want you to round this, and the calculator is automatically rounding if you don't give it further instructions. Then parentheses, what you want it to round in case this is your answer. Then how many numbers you want to round out the decimal in case, in this case, I wanted the nearest tenth. All right, so here are all the different ones that we're going through it. If you wanted the nearest whole number, no decimals at all, you can put 0, but you can see it's already doing that. So it's given me no decimals, but I could also do comma 0, and you'll see it will still be 4. If I want the nearest tenth, okay, so there's one number after the decimal because it's the number of zeros. So you can see here, if there's only 1 0, it's one number. If there are 2 zeros, it's 2 numbers. If there are 3 zeros, it's 3 numbers. That's how you're doing it. All right, so to the nearest tenth, all right, 10 has 1 0, so it'll be 1. So this is still 4. If I wanted nearest hundredth, it will be 2. And you can see there's 2 numbers. If I wanted nearest thousandth, TH, 3. And you can see that there are 3 numbers. So in my case, I want the nearest tenth, so I want 1 number. In my case, my answer is going to be 4 seconds. So what time will the rocket hit the ground? 4 seconds for me. All right, so when you get to the rounding ones, please make sure you follow in those directions. All right, the time at which the rocket would hit the max. Okay, so back to my question. When is it going to hit the max? The time. So here is my time. It's not something I need to round, so it's going to be 2. All right, so this is 2 seconds. All right, so now the only difference, again, we've done this before. The only difference is now we're using rounding as well. And all you have to do is type in the word round, parentheses, whatever you want the calculator to round, comma, how do you want it to round? All right, so you should have also answered yours, the height the ball was thrown from, the maximum height of the ball, the time that the ball would hit the ground. So all of that is pretty much the same thing that I was doing here, the time at which the ball will reach its max. What I want you to complete is, what does B of 1 equal to? And then also, what does it mean in context? So B of 1 is equal to what exactly? So you have to use the function B. All right, so if I use the function B, that's this one right here. All right, so how do I evaluate this function for x is equal to 1? So remember, this one is your x value, this one is your y value. So tell me what it's equal to and what does it mean in the context of this ball. Then you're going to answer which one was in the air longer. Was it B or R? And R is the question I was doing, because you can see it says R. All right, you're going to say which one was in the air longer. Was it B and R? And you're going to tell me what it is. So tell me what B of X, how long was that in the air? How long was this in the air? And then circle the one that was in the air longer. Which one went the highest? So again, tell me what B of X, how high it went. Well, what R, how high it went, then circle the one which is higher. Which one started at a lower height? Again, tell me what is the height of B, what is the height of R, and then circle the one that is higher. And that's how you just do projectile motion with rounding. Let's practice.